Hello, and welcome back to this tutorial series on 3D printing at nanoscale with f3ast. In the previous video, we've seen how to extract calibration parameters required for modeling Febit growth. In this video, we will see how to use these parameters for building Febit 3D nanostructures. So let's head over to the projects folder. Here, we're going to start by opening the examples folder and selecting a building notebook. We need to ensure that we are in the environment where f3ast has been installed. So first, we're going to import f3ast and numpy. And in the second cell, we're going to load the settings. By default, settings are defined in the settings.json file. And this has been described in more detail in the installation video. But when importing the program, these are just a dictionary or a name-value pairs. So they can be redefined in the script or manually fully defined. In the next cell, we're going to load the 3D structure. These are 3D structures in f3ast are defined in STL files. And f3ast also contains some basic functionality for modifying STL files once they're imported. These include stuff like rotating or tilting the file, mirroring it, centering it, rescaling it if it's too big or too small, and displaying it so that we're sure that we are building what we want to build. So this file consists of multiple spiraling nanowires, and the gray slab represents the XY plane. So the electron beam is coming vertically to this plane. Next, we here select the parameters that we acquired from the calibration that we've described in the previous video. And we decide to use here DD or desorption dominated model that requires growth rate, thermal conductivity, and sigma or defective beam size. So when the model is created, it computes all of the necessary parameters for the file, and it also slices the file. And here for the DD model, it computes the resistance. So the thermal resistance starts, we can see here it starts low when the structure and the wires are near the substrate. And as the wires are growing, the thermal resistance increases until the point where they all merge. And at that point, the thermal resistance quickly drops because there are now multiple paths to the substrate. Next, we use the stream builder to solve for dwells. So we can use this model to get the dwell times required to build the structure. This gives us two objects. One is a dwell solver that contains all of the information about how the solution has been acquired, and the stream builder that we can use to build the stream files that we can import into the microscope. So here we can show the solution. This is a heat map of all of the dwell times on the structure. This is sometimes difficult to interpret because depending on how the structure is sliced, the program can decide to do fewer long dwell times or more shorter dwell times. But generally we can see here that dwell times start low as the wires are fairly horizontal and near to the substrate, and as they're growing taller, the dwell times increase, and then we can again see a bit of a drop here when they all merge and when the resistance drops. Next, now that we are sure that the stream builder is created sensible dwells, we can get the stream and export it to a file. So here we export the stream to streamtest.str, and this is the file that can be imported into an electron microscope and used to build Febit 3D nanostructures. It's always also good practice to save the objects that were used to acquire this stream file. So with this cell, we save everything into streamtest.pickle file, and then we also demonstrate that we can load these objects and recover the structure that was built. So this now allows us to keep a reference of what each stream file represents, what the object was, and how the dwell times were solved. The next cell describes how we can use other models to get more accurate dwell times depending on the exact precursor or the exact needs that our structure has. But we'll go back and we'll try to build a slightly more complicated structure. So here I have the 3D structure of hand that was shown in the paper. And I'll just rescale it slightly because this is a fairly big structure, so it can take some time to compute all of the dwells. And then here we're gonna define the new growth model and plot all of the resistances. We can see that here the numbers are going to be much lower because the structure is just bigger and the thermal conductivity is going to be bigger. We can see that the fingers towards their tops get slightly hotter, but generally this is going to have very little effect from the heating. And then we can compute all of the dwells and see what that looks like. It can take a few seconds for bigger structures. And there we go. So this is the heat map of dwells again. And then finally, I can export it to a different file and import that file and build the hand in the electron microscope. And that's it for this video. Thanks for watching. I hope you found this useful and enjoy building 3D nanostructures using f3ast. Bye.